All right, so if you grab your unit circle chart, if you have that handy. If you don't, I've got a copy you can look at up here on the board. And when you lost it or something, go to the classroom, click the topic with unit circle, print one in the library or something. But you're going to want to shade these areas. These are the areas that are going to give you the answers that you need when they're looking for inverse functions. So on the sine and the tangent columns, you're going to want to shade the top quarter and the bottom quarter. So sine and tangent, top quarter to bottom quarter. Cosine, you're going to shade the top half. So that's what it should look like. I also have one up there by the date. You can look at it there if you can see it. Shade those because that will help you get the right answers on a quiz when I ask you for an angle. If you remember the inverse trig functions, which we technically have done already when we were in chapter 9 of geometry, inverse trig functions are going to help us find angles. And we know that if we have the angle, we can find the trig function of that angle. If we have the trig function, we can go backwards and find the angle just by doing inverse. So shade in those areas. And I want you to see what we're shading in. There's two specific intervals that we're looking at here. And what those shaded areas represent, basically, is it represents what the calculator is going to give you as an answer. Okay, because if you look at each column, if you look down the sine column, you can have a value of a half at 30 degrees. You can also have a value of a half at 50 degrees or 150 degrees. Both of those have the same sine value. So if I put in my calculator inverse sine, and if I'm in degree mode, and I hit inverse sine of 0.5, which is a half, what do you think is going to come out? Is the 30 going to come out, or is the 150 going to come out? So you click equals and 30. 30 is going to come out, not 150, even though 150 is a right angle. Your sine of 150 will be a half. That calculator is not going to give you that. The calculator is going to give you the value that is between this interval right here, between pi over 2 and negative pi over 2. And in degrees, it would be negative 90 degrees and positive 90 degrees. So it's going to give you a value inside of that interval. It's not going to give you a number greater than 90 or less than negative 90. Even though there are two values, there is a value of a sine value of 150, or the sine inverse sine of a half is 150, but that's not going to come out on the calculator. What you're going to get is the one that will come out on the calculator, which is the 30 degrees. So that's why I'm having you shade this in. Because if you want an inverse angle, you want to give me the angle that's in the shaded area. Okay, for cosine, so for sine and tangent, they're the same. For cosine, you can see that it's the top half. It's between 0 and pi. And in degrees, it would be between 0 degrees and 180 degrees. So if I'm looking at my answer here, let's say I wanted cosine of negative, the cosine of the angle is negative a half. Well, there's two places where the cosine could be negative a half. It could be negative a half at 120. It could be negative a half at 240. Which one do you think is going to come out of the calculator? If I put in inverse cosine of negative 0.5, am I going to get 120 or am I going to get 240? Which angles between 0 and 180 is what's going to come out on the calculator? Which one of those two, 120 or 240? Which one's between 0 and 180? 120 is. If I hit equals, boom, 120. You're not going to get the bigger angle. You're going to get the more reduced angle. Okay, that's what they're going to look for, the more simplified angle. So that's what you're looking for on these. You have to look in the shaded area. All right, let's go to the couple of examples. So arc sine and inverse sine mean the exact same thing. So you might have arc sine x, you might have inverse sine x, which is sine negative 1. those two are exactly the same. Usually, and this is just a general rule, but it's not exact, usually the arc sign is for radians and inverse sign is for degrees, but that's not always the case. It could be either one. So just know that they both mean that you're finding angles. So inverse trig functions means that you're finding angles. Finding angle measures. And we are looking for the angles that are between those intervals. Okay, that's what we're looking for. So if I'm looking for the inverse or arc sine of -1/2, where on your chart is the sign of -1/2? I see -1/2 at 210, which is 7 pi over 6. I see -1/2 way down here at the bottom, which is 330 or negative pi over 6 or 11 pi over 6. We need to find the one that is between our interval. So we've got all kinds of answers. We've got at, wait, what was it? -1/2. Sine is -1/2 at these two angles. Sine is -1/2 at all of these angles right here. So what would come out of the calculator if I put an inverse sine of -1/2? Well, you might look at this and say, well, -1/2 down here, the shaded area has 330 or 11 pi over 6. Problem is, 330 and 11 pi over 6 are not in our interval. We can only look between -90 and +90. That's our interval. So if I'm looking at this bottom of this chart, and if you notice in red, what I did is I numbered up negatives. So this bottom is at 360 or 2 pi. If I was to go down my unit circle and start by going down, you'd be going down to -pi over 6, -pi over 4, -pi over 3, -pi over 2. Okay, you'd be going to -30, -45, -60, -90. So that would be going from the bottom, moving up the bottom, from the bottom, moving up. So the angle that we want would be the -pi over 6 or the -30 degrees, depending on if we're in radian or degree mode. That would be the angle between my interval. That would be the number between -90 and +90. So right here, I'm going to put equals. I'll put -pi over 6 radians. I could also put -30 degrees, depending on whatever mode I was in. But that is the one that's between my interval. So again, if you put that in your calculator, inverse sine of -0.5, you're going to get -30 degrees. Comes out on the calculator. -30, if you put it in as radians, it would be -pi over 6, which is about -0.5 radians. So that's how it comes out. So where is the sine a +3/2? Where is the sine a +3/2? Not 3/2, radical 3 over 2, sorry, radical 3 over 2. A positive radical 3 over 2. Where is that? Where is the sine of positive radical 3 over 2? Okay, I see one here, but that's not in my shaded area, so we're not wanting that one. The other one is right there. That would be at 60 degrees or pi over 3 radians. So we'll put pi over 3 radians. We'll stay in radians right now. Pi over 3 radians. If you had it, it could be 60 degrees. Where is the sine value a 2? Do you see a 2 anywhere going down the sine column of your chart? No, there is not a 2. So let's test that in the calculator. Inverse sine of 2. Domain error. Why can't a sine have a value of 2? What's the highest the sine can go and the lowest the sine can go? Up to 1 and then down to -1. You'll never get a sine value of a 2. The reason is your hypotenuse, OH, SOH, H on the bottom, means your fraction is always going to be less than 1 or equal to 1. because your hypotenuse is on the bottom. It's going to make a fraction less than or equal to 1. So we got a sine of 2 here. That's going to be just an error, or we could put undefined. There's no value for that. Let's see, cosine. Where is cosine radical 2 over 2? In the shaded area. Because I know it's down here at the bottom, 315 in the non-shaded area. In the shaded area, radical 2 over 2 is at 45 degrees or pi over 4 radians. So we'll use the radians. We'll stay in radians right now. So we'll do pi over 4 radians. Where is the cosine a negative 1? In the shaded area. Cosine negative 1 in the shaded area. Negative 1 in the shaded area right there, 180. Negative 1, there's your cosine. Negative 1, and it's in the shaded area. There's also, I think that's actually the only negative 1. Yeah, that's the only negative 1 on there. Okay, so that would be pi radians. Where is the tangent 0? Where is the tangent a 0? In the shaded area, because there's a 0 in the middle for tan, but that's not in the shaded area. We need our answer to be between pi over 4 and negative pi over 4, so we need 0. We need 0 degrees or 0 radians has a tangent of 0. So 0 radians. Where is the tangent negative 1? Tangent is negative 1 in the shaded area way down here near the bottom. Tangent is negative 1 at negative pi over 4 radians. Negative pi over 4 radians. So negative pi over 4 radians. That's where the tangent would be a negative 1 value. The next 3 are just asking you to plug it into your calculator and see what you get. So you take your calculator, and we'll stay in radian mode, because they were wanting radians on these. You're going to put inverse tangent or arctangent of negative 8.45. Now in the calculator, it's still going to say tan negative 1. This is the same thing. Tan negative 1 of negative 8.45. It's the same thing in your calculator. And you're going to end up with negative 1.45. Inverse sine 0.2447 will give you 0.2472 radians. 0.2472 radians. That would be about a quarter of a radian. A fourth of a radian is about what that is. 0.25, almost 0.25. Inverse cosine of 2. Oops, domain error again. Remember, cosine and sine can't be more than 1 or less than 2, or less than negative 1. So that's another undefined value. You can't have a cosine equaling a 2. So that doesn't work. The last one are just asking us to write the theta angle as a function of x. How would you solve for this angle if you had both sides given to you? In this picture, we have this opposite side is x, and adjacent side is 4. So we have OA. We're going to be reviewing SOHCAHTOA again next section. So SOHCAHTOA, TOA, we would need tan. And we want inverse tan because theta equals an inverse. We want the angle. Theta is the angle. Inverse tan of the opposite x over the adjacent 4. You need the opposite on top. You need the adjacent on the bottom for TOA. So that's how you would solve it. If you were given that x, you could plug x in there and you could solve that angle. This angle right here, they're giving you opposite side and they're giving you hypotenuse. So your theta this time would be OH, which is SOH, so sine. And you're going to put x plus 2 over 5. That would be your opposite over your hypotenuse, OH, SOH. And so that's a review of our inverse trig functions from our geometry. Like I said, it was a really short section.